Floods strike without warning, storms tear through lives uninvited, but what if we could see disaster before it even arrived? What if technology could not just respond but warn, guide, and protect? This is the front end of a computational framework. Here, user can input a location, say Feni River, Feni, Bangladesh, along with intensity like 5 inches per hour and duration such as 150 hours. Once the submit button is hit, the system starts pre-processing the flood simulation. This typically takes about a minute, so while it's running, let's dive into the code to see how this all works under the hood. The first step is geocoding the user's input. We use Nominatim from OpenStreetMap to convert this into precise coordinate. Next, we define a bounding box around this point of 100 square kilometer area. With the bounding box set, we download a digital elevation model or DEM to Open Topography and pre-process it with the Whitebox Tools library. Pre-processing is critical. It involves algorithms like bridging depression, flow accumulation, and flow direction. Using the flow accumulation data, we set a threshold to extract major stream areas where enough water accumulates from channels. Then we identify the pour point, which is the pixel with the highest flow accumulation, representing where water exits in the system. Using this pour point, we run a watershed delineation algorithm to map the entire drainage basin feeding into that exact point. To make our flood prediction more realistic, we use land cover data from ESA. Now we calculate the peak discharge. We use the rational method, which is a standard hydrological approach. Then flood inundation is simulated using the bathtub model. This approach treats the watershed like a bathtub, filling it with water based on the discharge and duration. Finally, we visualize the result. We use matplotlib to create a 2D flood depth map, color-coded to show water depths across watershed. We use FloodVista to generate an interactive 3D model of the entire floodplain. This model let users rotate and zoom to see exactly how water spreads across the whole terrain, highlighting the vulnerable areas like low-lying villages. These visuals are crucial for communicating flood risk to stakeholders and get area-specific information.